Thank you, Maria, and thank you, Ivan. I have some slides to present, so just 1 minute while I find those slides. Okay, so good afternoon, everybody. So first of all, I would like to thank very much the forum for providing the opportunity for me to join this discussion. I'm Janette Stewart from Analysys Mason's consulting team. Analysys Mason is a global telecoms, media and technology consulting and research firm. So I'm going to be presenting today some highlights from some research that we've been doing recently into costs and benefits of deploying full capability 5G infrastructures in Europe. So we have undertaken recently 2 studies. The first study was on costs and benefits that full 5G deployment brings to some of the use cases that we have already heard from Ivan about across different sectors of the European industry. The second study assessed the cost and extent of 5G EMBB, so 5G mobile broadband coverage that will be provided by nationwide mobile network operators across European markets. So we have assumed a population-led EMBB coverage, and we have considered the costs of that relative to the costs of extending that EMBB coverage into the full capability use cases. We defined 5G as a flexible open innovation platform, which is shown on the slide here. So in other words, we're assuming that 5G supports cross-sector use cases and environments. Those multiple sectors are shown on the slide here. We've grouped into clusters. So we have 4 clusters as shown here: smart production and logistics, smart urban, smart rural, and smart public sector. So the use cases within each sector were selected and are shown on the slide here as being the ones that would typically use the full feature capability that 5G can offer, such as very high capacity connections, massive machine type connections, and low latency communication. So that's such that would be needed to facilitate sort of industrial digital transformation, industrial augmented reality or virtual reality, machine automation, remote piloting, and so forth. So moving on to the next slide and just showing the results of our first study. As a total open innovation platform, we estimated that full 5G deployment in Europe can deliver over 200,000 billion in benefit, and that is around about 50 billion euros of additional investment costs. So that is additional to the mobile broadband deployment, which mobile network operators are already undertaking in Europe. The benefits shown on the slide here also exclude benefits of consumer mobile broadband coverage, which is probably why our figures differ from some of the ones that Ivan just mentioned in the introduction. And we also excluded specific use cases such as road and rail in this initial study, and we then came back to them in the second study. So moving on to the second study. In the second study, we wanted to compare how that additional 50 billion of euro additional cost compares to the total 5G investment cost. So that is the investment being made by multiple mobile network operators in each of the European markets to roll out mobile broadband coverage. So in the second scenario, we looked at mobile broadband provided commercially by 3 or 4 national operators in each market, and we wanted to investigate total 5G investment. We wanted to look at how far that commercial investment might reach, so in terms of population coverage, geographic coverage in different European markets, and using a combination of frequency bands. So we were assuming the European portfolio of spectrum will be used, so 700 megahertz, 3.5 gigahertz, 26 gigahertz, plus legacy mobile bands. We also wanted to look at the additional commercial investment which might be expected to extend 5G coverage using 3.5 gigahertz together with 26 gigahertz to serve specific use cases. And finally, what investment might be needed potentially via public subsidy to achieve a universal geographic coverage using a low frequency 700 megahertz layer. So we had 3 scenarios. A base case, which is the MNO commercial deployment. We have a low frequency scenario, which is the final few percent of geographic coverage. And then we have a scenario C, which is the 3.5 gigahertz coverage footprint with additional 26 gigahertz in high capacity areas, giving us our full 5G capability. So the results of that final study are shown on the slide here. So what we found was that commercial investment being made by mobile network operators in Europe will total 150 billion euros largely by 2025, and that is across the EU 27 market, including also UK, Switzerland and Norway. So it's actually across 30 European countries. And this 150 billion is the total of all networks in each market. So in each market, we might have 3 or 4 competitive networks, depending on the level of competition. We modeled that this 150 billion euros will provide between about 30 and 60% of population coverage per market. But in geographic terms, that is only around about 10% of the geography of each market. Considering further 3.5 gigahertz deployment, we considered that a further 20 billion euros of investment can extend 3.5 gigahertz coverage. And that is a mixture of commercial investment plus an assumption of a single network, which is publicly subsidized to provide additional 3.5 gigahertz coverage. And then finally, our scenario about the low frequency 700 megahertz coverage for the final few percent was totaled at 4 billion euros across all markets. And that is the capital cost of a single shared 700 megahertz network by market. So that is perhaps why this figure seems so low. It excludes OPEX, and it also assumes a single infrastructure rather than having 3 or 4 multiple infrastructures in rural areas. Important to note finally that in the scenarios B and C, there's an assumption that not all of this coverage is commercially viable, and hence public subsidy would be needed. In scenario B, the cost is assumed to be 100% public funded, and then there's a split between the commercial and public funding for the scenario C. The other assumption, which is important, is that the same 5G infrastructure can meet the different requirements of the different use cases. So we're assuming network slicing and sort of 5G standalone networks with virtualization and so forth, so that coverage and capacity can be optimized and tailored to different use case requirements. We're also assuming, of course, that competing multi-use networks would be deployed within the commercially viable areas, whereas in the rural area, the cost is that of a single infrastructure. So with that, I would just like to conclude my comments. Thank you very much for listening, and I look forward to taking part in the Q&A. Thank you.